So you've been doing I think you had two wave gliders at Kilauea volcano. Has that mission just wrapped up, or is it still, or is it in the finishing phases now?
It's still going, and we're really kind of reacting to the scene as it evolves. The wave gliders do have other missions that they're involved with, but we've kind of been doing a little bit of tag team. But right now, one of the wave gliders is out there still mapping the kind of outer extents of the plume.
Okay.
Yeah.
And so what information do you hope to gain by doing this?
Yeah, so we've put a variety of different sensors on the wave glider for a variety of different interests. Started with an atmospheric sulfur dioxide sensor that was provided by an MIT group, a hydrophone for recording up close the sounds of the lava entry, which might be used by volcanologists that are recording from far away. To have that up close recording could be interesting. We've also been measuring our standard oceanographic variables that wave gliders measure all the time, ocean currents with an acoustic Doppler current profiler, which is actually kind of interesting the way the currents are being affected by this, waves, weather, but maybe the most important sensor for this mission is the flow-through fluorometer set at the surface. Also the CTDs. We have fixed depth CTDs mounted on two different umbilical lengths on the two different wave gliders. So we're getting some data on the sort of extent of the hot water plume at different depths. It's a remarkably shallow, plume of the sort of scalding hot water that comes off of the lava as it enters the ocean. So chlorophyll and CDOM and other fluorometer parameters are the primary data set that we're collecting day after day after day as we are surveying the area.
And how much longer do you plan to be able to do that?
We'll see. We're kind of contending with the wave gliders for other missions, and we might free up other wave gliders depending on really how much interest there is and how much longer the lava flow continues. I understand right now Fissure 8 is still flowing profusely. The other fissures have stopped, at least for the time being, but the lava from Fissure 8 is entering the ocean on a 6-kilometer stretch of ocean. And so there's still quite a lot of activity at this point, and nobody really knows, what's going to happen, whether it's going to continue this way or stop or accelerate. Nobody knows.
Well, we should back up a second, I guess, for the few people who might not know what wave glider is. Could you give sort of a quick history? You're the inventor of it, and it's done some really cool things. But just for those who might not know, what is wave?
So wave gliders are small unmanned surface vehicles. The surface expression is about the size of a surfboard, and it has solar panels on that component, and really no other moving parts. It's connected by an umbilical cable to a sub down below, which has wings on it. As the surface part pulls up and down due to wave action on the winged device down below, those wings create propulsion. Both during the upstroke and during the downstroke, the wings pull forward. There's a rudder at the back of that winged component, and that's how we steer wave gliders. And so as long as there's wave motion, they're moving forward. And all we have to do is give them a GPS, give them a waypoint or a waypoint course that we want them to travel to, and they can continue to do that while taking all of their energy from the natural environment. And since they're powered by waves, primarily for propulsion and also through the solar panels for the radios and sensors, they can stay out in the ocean for very long periods of time, really limited by sensor fouling and other issues like that, but not by power.
Okay. So you can carry instruments below the water, on top of the water, and communicate as well. Pretty much.
That's right. Yeah. So the original idea came from a project by the Jupiter Research Foundation, which is a small nonprofit organization run by Joe Rizzi, who's Liquid Robotics co-founder, and they were interested in monitoring humpback whale sound. So the initial idea was to have a remote control boat that could tow a hydrophone and position the hydrophone where in the best place to listen to whales, and send that back via radio. And to do that, they wanted something that could power itself. And so the energy harvesting project really began. But that mission of towing a hydrophone actually is at the core of many of the applications now where wave gliders have really been used a lot. Sometimes the hydrophone is listening for vessels, it could be surface vessels, it could be submarines. Other times it's a transducer, and we're acoustically communicating with other devices in the ocean. So wave gliders often get used as a communication gateway, where we're providing a satellite link or a radio link and an acoustic link to something on the seabed or another autonomous vehicle, it could be, that is using the wave glider for its telemetry, and it can use it for positioning as well. So there's a whole variety of uses around the acoustic aspect, and then a lot of other sensors can also be attached to wave gliders. We've done a lot to build a modular architecture where they can be rapidly configured, as we have for this LAVA mission, where we really adapted some wave gliders quite quickly that we had in Hawaii already and deployed them.
Okay, and so back to the volcano. Is this kind of study something that you were able to do before, just with say a manned boat, or divers, I guess, would be pretty iffy given what's going on in the water? Or is this the first time that you're really able to do these kind of measurements?
Yeah, so I think it is possible to get out there in a boat, and people have been doing that. It's actually quite remote. I went out there myself on a boat to check on the wave gliders and take some pictures. We lucked out on the weather. We had a really nice weather day, so it was only a couple hours a boat ride each way from Hilo. But oftentimes that's just not tenable. It's not the most accessible place. Also, getting right up close to where the lava is entering the ocean in a boat could be quite hazardous. The winds aren't subject to, aren't normally subject to shift rapidly there, so you can pretty much bank on the lays going the way that it was. But if it were to change direction and head over your boat, it could be quite a hazard. Also, as the lava enters the ocean, it can almost erupt at times, where it accelerates and blows rocks and chunks of debris quite high up into the sky. So it's a dynamic and not a safe place for people. But actually, maybe the main advantage of a wave glider is not so much the dirty or the dangerous, but it's actually the dull. It's the fact that they've been out there for a month now, just swimming back and forth doing transects. Scientists on a boat would not have that patience. It would be too expensive to do that sort of methodical, slow zigzagging back and forth, taking measurements every few seconds or whatever the timing is for the different sensors that we're operating. So just that sort of persistence, being able to stay out there for indeterminate periods of time has really been an advantage. We've collected a lot of water quality data on this project. I think that the scientists who are going to go through that are going to have a lot to digest. They do already, yeah.
Yeah, that was my next question. So how often are you sending data back? Is it a continuous thing or just at periodic intervals?
Yeah, so there's different ways we can do that. We can log data on board, obviously. And in this area, we have intermittent cell phone connection. So when we do have the cell phone connection, we can use that and send basically full resolution data back real time. But that's been a little spotty. So we rely on Iridium for kind of everywhere communications, but obviously that's a much slower data link. And in this case, Iridium's actually been, Iridium's normally very reliable for us, but I think because of the Navy RIMPAC exercise that's going on right now, they tend to take the available bandwidth, and we've been starved at times. So there's very, very variable data connectivity. So that's part of the interesting challenge on this mission, is just adapting to that. Okay.
Did you encounter any other challenges or unexpected problems that you needed to solve in the course of doing this?
Well, the very first one was just a wake up when we had a thermal event. We've got all kinds of different alarms and warning messages that wavegliders send back, but I don't recall ever getting an over temperature alarm while in the ocean. That's something that usually we worry about when we're on the deck of a ship and something's just sitting in the sun. But we did get over temperature alarms, and we think that at that point we actually sprung a leak in the fluorometer on the first waveglider, and send that back for repair. So very rapidly we entered into scalding hot water, which was perhaps in excess of what that old seal was able to take. That was one thing. I think the other part that's really we're working on now is the Monterey Bay Aquarium Research Institute is engaging their autopilot for controlling the waveglider, and this addresses that sort of tedious aspect. It's fairly easy to just set up a zigzag waypoint course and let the thing rip and not pay much attention to it. But if you actually want to adapt the sampling to what's going on and not spend a lot of time where the data is not so interesting, really, where it's interesting really is at the front, where the hot water is meeting the ambient water. And so to track that, you really want to be able to be constantly piloting the vehicle. To do that by humans is too labor intensive. And so MBARI has been employing a autopilot that is in Monterey. It's actually on a server there. And so, ideally, the autopilot would actually be on the waveglider, because it wouldn't have all those connectivity delays and disruptions to contend with. And so it could much more rapidly react to the environment. The problem with that is that we're tuning and changing the algorithm all the time. So that's the advantage of it being in a server in the closet in Monterey, is that we can, recode on the fly. And so there's reasons for doing it that way, but definitely these data outages have caused us some grief where the waveglider was cut off. Maybe a server goes down, but it's not just the comms link. There's a lot of different pieces in the chain when you're doing a control like that from remote. So I think that we knew this going in, but maybe this re-emphasizes that you really want to build the autonomy as close to the control point as possible, or the control point as close to the sensors and the device as possible. So I think if we were to do this again, it would be great to use a Regulus plugin. Regulus is the operating system on the waveglider. It's a Java operating system, and it supports plugins where people can write code modules that are safe to run. And actually they can be edited and loaded via cell phone. So if we were maybe a little bit more adventurous, that's what we could be doing on this mission. Yeah.
So did you learn anything from this deployment that would help with other similar work or even dissimilar work for waveglider in the future?
Yeah, well, I think that this general topic of how to get your in situ measurements where they're most useful is a really important one. Even if we had 10 million wavegliders in the ocean, if they were just in random locations, they mostly wouldn't be providing data that's that interesting. The interesting data occurs at these transition points. The analogy I sometimes use is if you asked a satellite what color the carpet was, it would say gray. If you asked an ant what color it was, it might say black, or it might say white, depending on which part of the carpet it's on. And so we're kind of closer to that ant. And so you have to keep moving around and getting a sense of what the overall picture is. And the ocean isn't, a geometric pattern like a carpet might be. It's a continuously evolving swirl of phenomenon. And we want to be able to move our in situ measurements to those points where they actually might impact the analysis that's going to be done, whether that's a forecast or whatever. And so this area of dynamic front tracking, which the MBARI folks are working on, I think is an area that really is going to be impactful and important for the utility of ocean in situ measurements in the future.
And who all will have access to the data that's coming from this study? Is it?
Yeah, so we're working closely with some researchers, and we'll make it available to whoever wants it. So if anybody's interested in it, reach out to us and we'll make it available to us. The most thirsty consumer right now is University of Hawaii. Dr. Stephen Colbert is there in Hilo, and he's lapping it up kind of on a daily basis and helping us, define the mission. And of course, the MBARI folks who are a little bit more focused on the technology of the autopilot. But the acoustic data, those recordings, and the other data sets we'll make available to whoever wants it.
Okay. So what is kind of the next step for the Wave Glider? You said you've always got some competing things that you could have some of them off doing. What's kind of the next?
Well, that's right. No, we always have, about a dozen wave gliders swimming around on the opposite side of the Big Island. That's where our engineering test center is. And so it's also where customers will come out and do integrations. And so the wave glider that's there right now, because it has this full oceanographic suite, including the acoustic Doppler current profiler, waves, and weather, is one that we like to use for performance characterizations. And so the next mission for it is actually to test the drag impact of a configurable payload when it's being towed behind wave gliders in various sea states. And so that's kind of a little bit more mundane, but some of what we do kind of on a daily basis out there in Hawaii. So the nice thing, though, is we'll just tell it to swim back. There's been an ongoing debate as to whether you take the south route or the north route around the Big Island. It's literally on the opposite side of the island. But I think we'll take the north route. It's a little bit more wavy. That's the windward side, so it's better fuel for the wave glider on that side. I think it'll be faster, but it just depends. The currents around the Big Island are always shifting, and so it's interesting in that way.
So you don't necessarily have to go pick them up. You can just whistle for them to come home.
Yeah, exactly. Well, even when they're just local in the in our test area, it's always easier to have the wave glider swim back to the harbor than it is to have the boat go out there. You just save time and fuel. We do. The last little bit is a boat picking it up. We don't actually swim straight into the harbor, just because there's a lot of vessel activity there, and we want to stay out of the way. But if we can swim the wave gliders to the mouth of the harbor and take our boat and pick a few of them up at a time, it saves time and energy for our guys in Hawaii. Yeah.
And how often you mentioned fouling from barnacles or whatever, how often does that occur? Because it seems like without that, you could go pretty much indefinitely.
Yeah, it really depends on the sensors. So sensors and the environment. The same sensor in the middle of the ocean, away from a lot of biological activity, can last for a long time. Then you swim it into a really productive zone, and it'll get fouled up quickly. So unfortunately, it is a big it depends. In this case, we think that the fluorometer might be fouled. The chlorophyll readings have been too high, so that's one of the reasons why we want to bring this wave glider home pretty soon, if nothing other than to just clean the fluorometer and check that, recalibrate it. The temperature readings, though, are still consistent. We have multiple different temperature sensors, and they're reading consistently with each other. So we believe that data, and so the survey that we're doing right now is really just focused on sea surface temperature and the CTD, slightly subsurface temperature. But biofouling will first affect sensors like that are measuring the water properties. And then the next thing they can affect is just the overall speed of the vehicle. If you become so covered in barnacles that you become encumbered. And then that also depends on how important that is. A lot of times our customers are just asking wave gliders to hold station. And as long as we can swim faster than the currents, we can be extremely fouled and still be okay. But, usually missions run months. 6 months is kind of a good period of time to then want to clean off the barnacles and redeploy, calibrate sensors and redeploy.
Okay. One more quick volcano question. Is this the hottest water that you've had wave glider operating in?
Yeah, I think so. We do have a customer that has that uses wave gliders for monitoring volcanoes, actually, in Japan. So I can't quite say what they've done. I don't know. They operate their wave glider, but certainly from what I've seen, this is the hottest water we've been in. When we went out there in the boat, I thought we might get closer. The boat captain was really leery of getting his outboards in that hot water. Their water cools, and he wasn't sure what would happen if he was in scalding hot water. And I couldn't argue. Double engine failure next to the volcano entering the ocean didn't sound like a lot of fun. So we kept a pretty safe distance when we were in the boat. Okay. The wave gliders were definitely closer to the lava than us. Yeah.
All right. In this case, being in hot water is not such a bad thing for a wave glider.
That's right. That's right.
All right. So is there anything we didn't discuss that we should have?
No, I think you asked some good questions. Yeah, it's a fun project to talk about. It's a really an amazing thing to see. I think the Hawaiians on the islands, some of them are really blasé. They say this, it's been erupting since the 80s, and it's no big deal. But if you can actually see it and get to that part of the island, it's a pretty big deal. At night the whole sky turns red. It's an amazing sight, and I think they are, now that it's been going on for months, they're pretty well set up to take tourists. So I would encourage people to go out and see it while it's going. Yeah.
Sounds good.
Yeah.
All right. Well, I appreciate your time today.
Yeah. Thanks a lot.
Thank you.